Good day everyone, welcome to our YouTube channel. This video is about review on complex number and basic operation. I will also be discussing some calculator technique and application of complex number in solving RLC circuit. Shoutout pala muna tayo sa APC students ko, Ronin, Julius, Carl, Jerome, Gerard, Ross, Chrysler, Alshi, Nathaniel, Florence, Marvin, Earl, Vince, Ivan, Kate, Angel, Joaquin, Glycel, Angelo, Raymond, Dave, Denbert, Carl, and Claude. God bless sa inyong lahat. Let's begin. Complex number can be in the form of rectangular and polar. So this is the rectangular form, represented by z, that is our complex number. And in the rectangular form, this is equivalent to a plus bi, wherein a is the real part, b is the imaginary part, and I is the identifier of the imaginary part. And also, I is equivalent to the square root of -1. While in polar form, z is equivalent to r, angle of theta, wherein theta is measured from the positive x-axis in clockwise or counterclockwise direction. Like for example, so let's say this is the r and the theta is here. So this theta is considered measured from the x-axis or the positive x-axis in the counterclockwise direction. And if that is the case, so counterclockwise direction, theta is considered positive. Take note for that. And if the theta, okay, is measured from the positive x-axis in clockwise direction, this is our theta in clockwise direction. Therefore, theta is negative. And take note for that. Let us have some examples. Example number 1, let's say z equals 3 plus 4i. So this is in rectangular form. Another example, z is 5 angle of 30 degrees. This is in polar form. Okay? Another example for, let's say z equals 8 minus 6i. Or this is example number 3. Example number 4, z equals 10 angle of negative 26.87. And this is degrees. Let us now discuss the rectangular to polar conversion and vice versa. So we will convert x plus yi. This is also the other representation of the rectangular form. Aside from a plus bi, we can also use x plus yi. Okay, to be converted to polar form, r angle theta. So we can denote this as x comma y, and this is r comma theta. So to convert that, we will be needing some equations and relationship. First, to solve the parameter r, okay, this is equivalent to the square root of x squared plus y squared. Okay? Then, for the theta, this is equivalent to the inverse tangent of y over x. Another equations, x is equivalent to r cosine theta and y equals r sine of theta. For example, convert 4 plus 3i to polar form. From this given rectangular form, x is the real part and equivalent to 4. Y is the imaginary part and equivalent to 3. So let us solve 3 or r. This is equivalent to the square root of 4 squared plus 3 squared. And this is equivalent to 5. Then, to solve for theta, this is inverse tangent of y over x. And this is equivalent to, so inverse tangent of 3 over 4, this is equivalent to 36.87 degrees. But before you write your final answer, you have to check the location of your theta. So to do that, let us plot the theta. So this is the x and y axis. Check the value of x. X is positive. And check the value of y. Y is also positive. Therefore, the theta lies in this quadrant. Okay, so this is the 36.87 degrees. So since the theta is with respect to the positive x-axis, that is now your final value for theta. And your answer here is, in the polar form, z equals 5 angle of 36.87 degrees. Next, let us now solve the conversion or perform the conversion using your calculator pole or rect function. To do that, so check your calculator, check the location of the pole, okay, or the rect function of your calculator. In this calculator, pole is located above the positive or the addition button. While rect, by the way, pole is polar, okay? Then rect is rectangular, located above the minus button. So since we are converting rectangular to polar, or meaning we need a polar value, so we have to call the polar function. So to do that in this calculator, press shift, then go to the polar button, so press that button. It will appear on your screen this function, pole open parenthesis, then you have to put x comma y. That put x comma y, that is the value of x and y. So this is 4 comma 3. Then put close parenthesis and press equal sign. It will show the value for r, which is 5, and theta, which is 36.87 degrees. Example number 2. Convert 4 minus 3i to polar form. So to do that, let us identify x. This is x. X equals 4. And this is y. Y equals negative 3. So to solve for r, this is the square root of 4 squared plus negative 3 squared. And this will give us 5. Next, solving for theta. Theta is the inverse tangent of negative 3 over 4. Okay? And this is equivalent to inverse tangent of negative 3 over 4 is negative 36.87 degrees. Okay? So this is negative because if you plot this theta, so x is positive while y is negative, and this is the location of your theta. Okay? So this is negative because this is in clockwise direction as stated earlier. So this is negative 36.87 degrees. Therefore, our final answer here, z equals 5 angle of negative 36.87 degrees. Let us now apply the calculator in solving the polar form. So press shift, then get the pole function and enter 4, comma, negative 3. Then close parenthesis, press equal sign, and the answer is r equals 5. Theta equals negative 36.87 degrees. Next, example number 3. I will be using calculator function for this example. Convert negative 4 plus I to polar form. So press shift, then polar, negative 4, then comma, and positive 1. Close parenthesis equals. So the answer for this is 4.123 and theta is 165.96. Okay? So this is our final answer for number 3. Z equals 4.123 angle of 165.96 degrees. Example number 4. This time we will convert polar to rectangular. So convert 3 angle of 23 degrees to rectangular form. R is 3 and theta is 23 degrees. So to determine the rectangular form, we need the values for x and y. So from the given formula from the previous slide, x equals r cosine theta. So theta is 23 degrees. Therefore, this is 3 cosine 23. The answer is 2.76. Y equals 3 sine of 23 degrees. So 3 sine of 23 is 1.17. Therefore, our final answer is z equals 2.76 plus 1.72 I. This is our final answer. Next, let me show you the solution using the calculator function rect. So shift, then the rect function, you have to input r comma theta. So this is 3 comma 23. Then close parenthesis and press equal sign. This will give you x 2.76151456, but we'll be using up to 2 decimal places. So just like our answer using the formula, x is 2.76. Then press the right arrow in your calculator to show the value for y. Y here is 1.7219 and so on. Our solution or our answer from our solution, 1.72. Okay, so this is our answer using formula and calculator function. For example number 5, let us use the calculator function, convert 5 angle of negative 42 degrees to rectangular form. So press shift and rec in your calculator, input 5 comma negative 42, close parenthesis and press equal sign. So this is our answer, 3.7157. Then move the cursor or press the right arrow, y equals negative 3.3456 and so on. Again, so for our final answer, z equals 3.72 minus 3.35i. Let us now discuss the operation in complex number. We will be discussing this basic operation only: addition, subtraction, multiplication, and division. Like for example, let's say we have z1 equals a plus bi, and for z2 equals c. So let's say c. C plus di. So to perform the addition, for example, z total equals z1 plus z2. So in addition, we have to transform every complex number to rectangular form. Okay? So addition, perform this in rectangular form. So since z1 and z2 are already in rectangular form, so we just need to add the real part to real part, and add the imaginary part to imaginary part. Okay? So that is the addition operation. While for subtraction operation, this requires also the complex numbers in rectangular form. So if we are asked to find z total equals z1 minus z2, so this is simply means a plus bi minus c plus di. And you have to perform also like in addition, that you have to group real to real part and imaginary part to imaginary part. Therefore, this is equivalent to a minus c plus b minus di. While for multiplication operation, let's say we already transform, okay, the given complex number into polar. So let's say z1 equals r1 angle of theta 1. z2 equals r2 angle of theta 2. because in multiplication and division, this requires that the complex number must be in polar form. So you have to convert, okay, before performing this operation, you have to convert the complex number in polar form. So to illustrate that, let's say Z total is Z1 times Z2. So this is simply equivalent to R1 angle of theta 1 times, so let us put parenthesis, R2 angle of theta 2. Let me erase that. Angle of theta 2. Okay? So multiply R to R, therefore we have R1 times R2, and for the theta you have to add that. So theta 1 plus theta 2. Okay? If theta 2 is negative, so you have to carry the sign. So this is the operation in multiplication. Multiply the R's and add the thetas. Next, in division, this is how you are going to do the division. Let's say Z total is Z1 over or divided by Z2. So this is equivalent to R1 angle of theta 1 over R2 angle of theta 2. So the operation is you have to divide R1 by R2, and for the angle, the numerator angle minus the denominator angle. So theta 1 minus theta 2. This is the operation of complex number under division. Okay? So let us have some examples. Number 1, Z equals A plus B, wherein A is 3 plus 5i. Put parenthesis for the groupings, plus B, this is 2 minus 7i. So to do that, since the operation is plus or even minus, we need the rectangular form of the complex number, but the given complex number is already in rectangular form. So you just need to add the real part to real part and subtract or add the imaginary parts. So the answer or solution for this is simply 3 plus 2 for the real part plus 5 minus 7i for the imaginary part. And for the final answer, this is 5 plus negative 2. So this is negative 2i. This is for number 1. For number 2, Z equals A. So A is 3 plus 5 again. Minus C. C is 10 angle of 30 degrees. So using your calculator or any method, convert 10 angle of 30 degrees. I will just put the conversion here. So I will be using my calculator function rec. So this is 10, 30. So for 10 angle of 30, this is equivalent to 8.66. Okay, and plus 5i. So we can now perform the operation. This is 3 minus 8.66. Okay, parenthesis, then plus 5 minus 5, parehas na 5. Therefore, this is 3 minus 8.66, negative 5.66 plus 0i, or simply negative 5.66. So this is the answer for number 2. Okay? So for number 3, B plus D. So B is 2 minus 7i plus D, 5 angle of 60 degrees. Okay? So let me move my solution here. So this is 2 minus 7i. Convert 5 and angle of 60 to rectangular. 5 angle of 60. So you just use any method. Okay, using formula or the rec function from your calculator. And this is equivalent to 2.5 plus 4.33i. So therefore, our answer is, so I will add directly the real part and the imaginary part. So this is 2 plus 2.5, we have 4.5, and negative 7 plus 4.33 for the imaginary. So this is equivalent to negative 2.67i. Next, I will be introducing also another calculator technique. So this calculator technique is limited to some higher version of the calculator or some higher edition of your calculator. For example, this Casio 570. So this model or unit has a function which is called complex. So here, you can use the mode function and choose the complex. This is in option number 2. So press that number 2 and you will enter in the complex mode operation of this model of calculator. So all you have to do is key in the complex number. For example, 3 plus 5i. So you can put parentheses. 3 plus 5i is in the eng button. Then close parentheses. Okay. Plus 2 minus 7i. Then close parentheses. Then press equal sign. So this will give you directly the answer. 5 minus 2i. If you want to convert 5 minus 2i in polar form, you can simply press the shift, then look for the keypad correspond to the complex. This is number 2, and then you have the options here, but consider for the meantime option 3, the R angle theta. So press 3. So this is the conversion of 5 minus 2i. This is the square root of 29 angle of negative 21.8. Okay? Now for number 2. So let me show you the solution for number 2 using the mode complex of this calculator. So 3 plus 5i, key in that 3 plus 5i. Of course, use the open and close parentheses. Then, you can directly input the 10 angle of 30 without converting this to rectangular. So let me do that and show that. So minus 10 angle, look for the angle button. So this is located in the memory A. So what do you call this button? The parenthesis minus or memory A? So look for that. So press shift and that button, so you have the angle symbol in your calculator. So this is 10 angle of 30. So that's it. You can press equal sign without converting all complex number to rectangular form. So press equal sign. So this will give you 3 minus 5 square root of 3. And this is all real part. So you can press this button to make this in decimal form. So you have negative 5.66 equal to our previous answer. This is without the imaginary part. We already cancel it using the conventional method. Okay? So I hope you can explore your calculator using the mode function. So let us solve this. Number 3. Okay? So this is 2 minus 7i close parenthesis plus 5 angle of 60. Then press equal sign. And that's it. Our calculator is in fractional form, so we can check this button. So this is 4.5 minus 2.6698 and so on, I. And this is equivalent to our answer. 4.5 minus 2.67 using 2 decimal places, I. Example number 4, z equals b times c. So let us solve this using conventional way. Number 4, z equals b 2 minus 7i times c 10 angle of 30 degrees. We have to convert first to minus 7i to polar form. So you can use any method, conventional or using the pole function of your calculator. So this is equivalent to 7.28 angle of negative 74.05 degrees times 10 angle of 30. Then you have to multiply 7.28 and 10. So 7.28 times 10 is simply 72.8. And you have to add the angles. So negative 74.05 plus 30 degrees. This is equivalent to negative 44.05 degrees. And for number 5, z equals c, that is 10 angle of 30 degrees times d, which is 5 angle of 60 degrees. So since all the complex numbers here are already in polar form, so we can perform the multiplication directly. So 10 times 5 is 50. Angle of 30 plus 60 is 90 degrees. So our answer is in polar form. If you want to check the answers in rectangular form, so you can use the rec function of your calculator. So let us check the answer for number 4. Convert that to rectangular. 72.8 and negative 44.05 degrees. And this will give us 52.32 minus 50.62i. So this is in rectangular form. While for number 5, let us convert that to rectangular form, 50 and angle of 90. this will give us 0 real part plus 50i. Okay? Let us now use the mode 2 function of your calculator. So press mode 2 for the complex operation. Then enter the given operation. So this is parenthesis 2 minus 7i close parenthesis times 10, okay, parenthesis 10, shift to press the angle 30 degrees, then close parenthesis and press equal sign. So the first answer here will give you the rectangular form. Okay? So just press the decimal conversion. 52.32 for the real part and minus 50.62 for the imaginary part. So that is the first answer from the calculator in rectangular form. If you want to get the polar form, so you have to press shift two and 3, then press equal sign. So the answer in rectangular form, so you have to press this to convert that in decimal form. So the answer in rectangular or polar form rather is 72.8, angle of negative 44.05. The same answer with our conventional calculation. That is for number 4. Let us check our answer for number 5. So press AC in your calculator. But since we are already in the complex mode, so just key in the given operation. And this is 10, angle of 30 times 5, angle of 60. Then press equal sign. So this will give us 50i, just like our answer with the conventional method. And convert this to polar form, shift 2, 3. Then press equal sign. So this is 50, angle of 90. Example number 6. Z equals A 3 plus 5i divided by C 10, angle of 30 degrees. So let us convert the numerator to polar form. So pole 3, 5. Okay, so calculator will give us 5.83, angle of 59.04 degrees over 10, angle of 30 degrees. So divide 5.83 over 10. This is 0.583. For the angle, 59.04 minus 30. So we have 29.04 degrees. So this is our answer for number 6 in polar form. So let us convert this in rectangular form. So I will be using the rec function from my calculator. So rec 0.583, 29.04. And this is equivalent to 0.51 plus 0.28 I. So this is in rectangular form. For number 7, Z equals D divided by C. D is 5 angle of 60 degrees divided by C, which is 10 angle of 30 degrees. So 5 divided by 10 is 0.5. For the angle, 60 minus 30. That is numerator minus denominator. So 60 minus 30 is 30 degrees. This is in polar form. Let us convert this to rectangular form. So rec of 0.5 and comma 30 degrees, and this is equivalent to 0.43 plus 0.25 I. So this is our answer for number 7. Let us now use the complex mode of the calculator. So let us key in the given operation for number 6. Okay, for the division operation, let us use this fraction function of the calcu. Enter 3 plus 5i in the numerator. For the denominator, 10 angle of 30. Then press equal sign. Then press this button to convert the answer in decimal form. So the decimal form is 0.5098 or 0.51. That is also our answer in our conventional method. Plus 0.28301 and so on I, or 0.28I. Okay, our answer from the conventional and from the complex mode of the calculator are the same. So let us now convert the answer from the calculator to polar form. So press shift 2 and 3. Press equal sign and convert the answer from your calculator to decimal form. So we have 0.583. So that is also our answer from the conventional method. Angle of 29.036. Our answer from the conventional method is 29.04 degrees. Okay, so the same answer from the conventional and to this complex mode calculator technique. Let us check the answer for number 7. So fraction function, press the fraction function, then 5 angle of 60. Then go to the denominator, 10 angle of 30. Then press equal sign. So convert to decimal. Our answer in calculator, 0.43 plus 0.25i. The same with our conventional solution. Convert to polar, press shift 2, 3. And equal sign, the answer is 0.5 angle of 30 degrees. Okay? Let us now discuss the application of complex number to RLC. Please take note of the following. R is the real part. So the resistance in the RLC circuit is the real part in the complex number system. For the XC, which is equivalent to 1 over 2 pi FC, the result here is in imaginary. So you have to put I. And take note, this is negative in sign. So negative XCI. While for XL, which is equivalent to 2 pi FL, this is also the imaginary part, and this is equivalent to positive XL I. Okay? And also take note, in RC circuit, current leads the voltage by theta. In RL circuit, the voltage leads the current by theta. In RLC, if XC is greater than XL, therefore I leads the voltage by theta. But if XL is greater than XC, the voltage leads the current by theta. Okay? So this relationship is for, by the way, this is for series connection. Let us have some example. This is a series RC circuit. So since this is a series RC, therefore the current leads the voltage by theta. And what is the value of theta? Okay? So first, let us solve XC. This is equivalent to 1 over 2 pi times the frequency, which is 60 Hz. This is the frequency. Multiplied by the capacitance. This is the capacitance, 10 microfarad. Okay. So this is equivalent to, so let us solve that operation. And this is equivalent to 265.26 ohms. Okay? So let us now solve the total resistance of this series connection. The total resistance is equivalent to the so-called impedance. And impedance is represented by letter Z. Okay, in RLC circuit discussion. This is called the impedance. And for the series connection, as we all know, series connection, to solve for the total ohmic value, we just need to add all the ohmic values. So in this case, this is R, that is the ohmic value for the element R, plus, or rather minus, because the ohmic value of XC, as we discussed earlier, that is correspond to negative I. So this is the formula for series RC circuit. It composed of real part and imaginary part. Okay? So this is now equivalent to 450 minus 265.26 I. So this is in ohms. You can convert this to polar form. So in polar form, you can use any method. You can use the pole function of your calculator. So 450, negative 265.26. And this will give us 522.36. Then angle of negative 30.52 degrees. Okay? So in RLC computation in your circuits, the impedance is equivalent to 522.36 ohms. And the theta is equivalent to 30.52 degrees. And since this is negative, it means capacitive circuit. The negative here, it means capacitive circuit, or I leads the voltage. Okay? So this is our answer for this circuit. So we can put 30.52 degrees here. The negative sign correspond to capacitive circuit, or more capacitive. Let us solve this example using our mode 2 function in calculator. So our calculator now is already in complex mode. So let us input our operation, that is 450 minus 265.26 I. And this is equivalent to, okay, first this is in rectangular form. You can press shift 2 3 to make it in polar form, and the answer here is 522.36. that is our impedance. And move the arrow to get the angle. This is negative 30.52. okay. And also, you can use that angle in solving the power factor. So the power factor is equivalent to cosine theta. So this is cosine 30.52. So cosine 30.52 is 0.86 leading. So meaning I leads the voltage. So this is a leading power factor. Next example, this is a series RL circuit. And for series RL, voltage leads the current by theta. Okay? So first, let us calculate XL. This is equivalent to 2 pi times the frequency. This is our frequency, 60 Hertz, times the inductance. This is our inductance, 100 millihenry. And this is equivalent to 37.699 ohms. So XL will be our imaginary part in calculating the impedance. So the impedance for the series RC is the addition of all ohmic values. So that is R plus XL I. So take note, XL is the imaginary part and this is positive. So this is the equation for series RL circuit. So let us substitute the values. We have 120 plus 37.699 I. So this is the rectangular form already for the impedance. Convert this to polar form. So we have 120 and 37.699. The polar form is 125.78. Angle of 17.44 degrees. So this is in ohms. Therefore, our impedance is 125.78 ohms and the theta is 17.44 degrees. So meaning V leads I by 17.44 degrees. We can also solve for the power factor, that is cosine of 17.44 degrees, and the result is cosine 17.44, and that is 0.95. And since this is more inductive, we have to put lagging. That is also the indication of positive theta. You can also use your calculator. To double check your answer. So key in the operation if you're already in complex mode. So we have 120 plus 37.699 I. Then convert this to polar, press shift 2-3 and equal sign. So this is the result, 125.78. that is the impedance, and for the angle 17.44 degrees. For the series connection of RLC, so let us solve first XL. This is 2 pi times the frequency 1 kilohertz times the inductance of 50 millihenry. So this is equivalent to 314.16 ohms. For XC, this is 1 over 2 pi times the frequency 1 kilohertz times the capacitance 0.2 microfarad. So let us solve XC. So this is 1 over 2 pi times 1 kilohertz times 0.2 micro. This is equivalent to 795.77 ohms. To solve for the total resistance or the impedance, so since this is in series connection, we just need to add the ohmic values. So R plus the XL imaginary, so that is positive, okay, XLI, minus XC imaginary, that is negative, XCI. Okay, so this is 1000 plus XL is 314.16 I minus XC 795.77 I. So perform the operation. We have 1000 for the real part. For the imaginary part, this is obviously negative. So 314.16 minus 795.77. And this is negative 481.61. So I. This is in rectangular form. Let us convert that to polar form. So that is, so polar function in our calculator, then input 1000 and negative 481.61. This will give us 1109.93 angle of negative 25.72 degrees. Okay? So from the given polar form result, we can conclude that impedance is 1109.93 ohms. And the theta is negative. It means more capacitive. So this is more capacitive because XC is greater than XL. So therefore, we can compute the power factor equals cosine 25.72, and this is equivalent to 0.9, and since more capacitive, leading. Current is leading the voltage by 25.72 degrees. So this is the calculation of impedance using complex number operation. Another example, this time this is a parallel RLC circuit. So let us recall in the calculation of the parallel resistance, this is equivalent to the total resistance is 1 over R1 plus 1 over R2 plus 1 over R3 and so on, depending on the number of elements connected in parallel. So let us go back to this given problem. Let us solve the XL first. So this is 2 pi times the frequency 60 times the inductance of 20 millihenry. So let us solve that. This is equivalent to 7.53. Let us use up to 4 decimal places. 0.5398 ohms. For XC, this is 1 over 2 pi times 60 times the capacitance, 100 microfarad. Okay, let us solve that, and that is equivalent to 26.5258. So therefore, the total resistance here is the impedance, and the impedance is the total ohmic values. But since this is in parallel connection, so this is our solution for the impedance. 1 over R plus 1 over positive XLI plus 1 over negative XCI. So for the substitution, let us use this space. So our solution now is here. So 1 over R, which is 20, plus 1 over 7.5398I plus 1 over 26.5258 I, and this is negative. Okay, so we already have a complex operation here. Take note, this one is real part of the complex number, so automatic, the angle for 1 is 0 degrees. So all 1 here is considered real part, and convert that to polar, the angle is 0 degrees. So all 1 is converted to polar form. Let us now convert the denominator here to polar form. Okay? So 20, convert that to polar. This is 20 angle of 0 degrees. 7.5398i, convert to polar. Take note, the imaginary part here is 0. Rather, the real part. So this is equivalent to 0 plus 7.5398i. Convert to polar, this will become 7.5398 angle of positive 90 degrees. While for this part, negative 26.5258, the real part is 0. Okay? And minus 26.5258, that is the rectangular form of this portion. Convert to polar, this will become 26.5258 angle of negative 90. So therefore, let us apply the operation of complex number, since the division requires the complex number in polar form. So this is the main numerator, 1 angle of 0 degrees. For this part, let us perform the division. So 1 angle of 0 divided by 20 angle of 0, and that is 0.05 angle of 0 degrees. While for the second part, second portion, so this portion, 1 angle of 0 divided by 7.5398 angle of 90. So that is 1 over 7.5398. So this is equivalent to positive. Let us use the 4 decimal places, 0.1326. For the angle, that is division operation, so 0 minus 90 is negative 90 degrees. Next, for the last part, that is 1 angle of 0 divided by 26.5258 angle of negative 90. So we will divide 1 by 26.5258. And that is equivalent to, using 4 decimal places, 0.0377. For the angle, that is 0 minus negative 90, we have positive 90. As you observe in the denominator, the operation now is addition. So we have to convert the denominator to rectangular form. So in the numerator, we still have 1 angle of 0 degrees. For the first part of the denominator, that is equivalent to real part only, and 0.05, that is equivalent to 0.05 plus 0 imaginary part. For the second part, this has a 0 real part, but the imaginary part is negative. So this is 0.1326 I. For the third part, convert this to rectangular form, and this is equivalent to positive 0.0377 I. So no real part. Now we can now perform the operation in the denominator. Okay? So we have in the numerator 1 angle of 0, in the denominator 0.05. Then let us perform negative 0.1326 plus 0.0377. That is for the imaginary part. And this is equivalent to negative 0.0949I. Okay, so let's bring the solution here. So we have now 1 angle of 0 in the numerator divided by, we have to convert the denominator to polar form. So let us convert that 0.05 and negative 0.0949. So the imaginary or the polar form of the denominator is 0.1073. So using 4 decimal places. For the angle, negative 62.22. So let us use 2 decimal places for the angle. And for the final solution, numerator 1 angle of 0 divided by denominator 0.1073 angle of negative 62.22. So we have 9.32. Let us use 2 decimal places since this is the final answer. Angle of 0 minus negative or 0 minus, yes, negative 62.22. So positive 62.22 degrees. So from this polar form, we can conclude the impedance is 9.32 ohms. This is the answer using the complex operation conventional method. Let us now use our calculator in the calculation of the impedance of this parallel RLC. So let us produce the fraction. Make sure that you're in the complex mode. So the numerator is 1 over 3 fractions. So let us create the 3 fractions. For the first fraction, this is 1 over 20. For the second fraction, this is 1 over 7.5398. Okay? I. For the third fraction, this is 1 over negative 26.5258 I. And that's it. After entering the required values, you don't have to convert going to rectangular, back to polar, then going to rectangular and back to polar. So this is the solution using the calculator complex mode. Just press equal sign, and the first answer is in rectangular form. Convert that to polar. So shift 2, 3. Press equal sign, and this is the answer for the impedance, 9.32. Okay, so that is how to calculate the impedance of a RLC circuit. You can check also the angle. So the angle here is 62.22. Okay, so this is our answer for this example. The impedance is 9.32 ohms. This is the end of my video lecture. Thank you for watching this video, and you can leave a comment. Also, please like, share, and subscribe to this channel. Thank you, and God bless to all.